The cosmos holds many mysteries that continue to fascinate scientists and enthusiasts alike. One such intriguing question is whether a star can turn into a planet. Stars are massive glowing spheres of hot gases, primarily hydrogen and helium, undergoing nuclear fusion. Planets, on the other hand, are cooler, solid or gaseous bodies that orbit stars. The concept of a star transforming into a planet challenges our basic understanding of these celestial objects. Could the remnants of a star, after it has exhausted its fuel, resemble a planet? What processes would be involved in such a transformation? Understanding whether a star can turn into a planet isn't just about categorizing objects in space. It's about comprehending the life cycles, evolution, and interconnectedness of the universe. This journey into the unknown continues to inspire and challenge our existing scientific paradigms. To explore the potential transformation of stars into planets, we must first understand the fundamental differences between the two. Stars are born from clouds of dust and gas in space. Through the force of gravity, these clouds condense and heat up, eventually igniting nuclear fusion. Planets, however, do not produce light on their own. They form from the leftover material that orbits a star after its birth. Despite these differences, stars and planets share a common origin in stellar nurseries. This connection hints at the possibility that under certain conditions, the remnants of a star could resemble or even become a planet. The idea of stellar remnants taking on planetary characteristics is a fascinating area of study in modern astronomy. This foundational knowledge sets the stage for exploring whether a star can indeed become a planet. Understanding stellar evolution is one of the most challenging aspects of astronomy. Stars have long lifespans, often millions to billions of years. Astronomers piece together information from stars at different stages. Stellar evolution begins with the birth of a star in a molecular cloud. This phase, known as the protostar stage, involves the gradual accumulation of matter. As the protostar grows, it heats up and starts nuclear fusion. This marks its transition into the main sequence phase. The life cycle of a star is a fascinating journey that begins in the dense regions of molecular clouds, often called stellar nurseries. Here, gravity pulls together dust and gas to form clumps, which eventually become protostars. During the protostar stage, the clump continues to gather more material and heat up, causing it to glow faintly. As the protostar's core temperature rises to millions of degrees, nuclear fusion begins. This process marks the birth of a star. The star then enters the main sequence phase, where it spends the majority of its life. During this phase, the star maintains a delicate balance between the inward pull of gravity and the outward pressure from nuclear fusion. Stars on the main sequence vary in size, temperature, and brightness. Eventually, a main sequence star will exhaust its hydrogen fuel, leading to an expansion into a red giant. This transition marks the beginning of significant changes that could lead to the formation of planet-like objects. When a star like the Sun exhausts its hydrogen fuel, it enters the red giant phase. During this stage, the star's outer layers expand dramatically and its core contracts. The expansion causes the star to lose mass, as its outer layers are ejected into space. This process forms a glowing shell of gas and dust, known as a planetary nebula. The core that remains after the outer layers are ejected is incredibly dense and hot. This remnant, called a white dwarf, represents the final evolutionary stage for low to medium mass stars. White dwarfs do not undergo nuclear fusion, but instead gradually cool and fade over billions of years. For more massive stars, the end of life is even more dramatic, undergoing supernova explosions. The remaining core can collapse into a neutron star, or, in the case of the most massive stars, a black hole. This recycling of stellar material is a key aspect of the cosmic cycle. Brown dwarfs are fascinating celestial objects that bridge the gap between stars and planets. They are often referred to as failed stars because they form like stars but lack sufficient mass to sustain nuclear fusion in their cores. As a result, brown dwarfs do not shine as brightly as stars and have cooler temperatures, similar to those of giant planets. The study of brown dwarfs provides valuable insights into the possible transformation of stars into planet-like objects. These substellar objects have masses between those of the heaviest gas giant planets and the lightest stars. Recent discoveries have revealed that brown dwarfs can have complex atmospheres and weather patterns, much like giant planets. They can also possess moons and rings, adding to their planet-like qualities. By studying brown dwarfs, astronomers can gain a better understanding of how stars and planets are related and how one might evolve into the other under specific conditions. Astronomy is an ever-evolving field, with new discoveries constantly reshaping our understanding of the universe. In recent years, powerful telescopes and advanced technology have unveiled many surprises about stars, planets, and everything in between. One of the most exciting areas of research involves the study of brown dwarfs and their potential to become planet-like objects. In 2020, astronomers using the Hubble Space Telescope made a groundbreaking discovery of a brown dwarf with a complex atmosphere, including clouds and potential rainfall. Another significant discovery came with the identification of free-floating planetary mass objects, sometimes referred to as rogue planets. These objects, which do not orbit any star, further blur the line between stars and planets. Some scientists speculate that these rogue planets could be the remnants of brown dwarfs or even stars that have lost their outer layers. These discoveries challenge the traditional boundaries of celestial classifications and open up new avenues for research. The recent findings in astronomy have profound implications for our understanding of celestial bodies and their evolution. The discovery of brown dwarfs with planet-like characteristics, as well as free-floating planetary mass objects, suggests that the universe is more diverse and complex than we ever imagined. These objects challenge our traditional classifications and prompt us to reconsider the definitions of stars and planets. One of the key implications is the possibility that celestial objects exist on a continuum, with characteristics that overlap between stars and planets. This continuum suggests that under certain conditions, a star could indeed evolve into a planet-like object. These findings also emphasize the importance of studying the end-of-life stages of stars. By understanding how stars shed their outer layers and what happens to their cores, scientists can gain insights into the potential for these remnants to evolve into planet-like objects. This research could shed light on the life cycle of celestial bodies and the processes that govern their transformations. The universe is a vast and mysterious place filled with celestial bodies that continue to surprise and intrigue us. The possibility that stars could turn into planets adds another layer of wonder to our exploration of the cosmos. Despite significant advancements in technology and our understanding of astrophysics, many questions remain unanswered about the nature and evolution of these objects. One of the biggest mysteries is the exact process by which a star could become a planet-like object. While the existence of brown dwarfs and rogue planets suggests that such transformations are possible, the specific mechanisms and conditions required are still not fully understood. Researchers are continually working to develop models and conduct observations that could provide more clarity. Understanding these factors is crucial for piecing together the complex puzzle of stellar evolution. The journey is far from over, and the potential for future breakthroughs keeps scientists and enthusiasts alike looking up at the stars in wonder. The future of astronomical science is bright, with many exciting developments on the horizon. Advances in telescope technology, such as the James Webb Space Telescope, promise to provide unprecedented views of the universe, allowing us to observe celestial bodies in greater detail than ever before. These observations will be crucial for understanding the potential transformation of stars into planet-like objects. In addition to technological advancements, international collaborations and missions are set to expand our knowledge of space. Projects like the European Space Agency's Gaia mission and NASA's upcoming exoplanet explorations aim to map the Milky Way and discover new celestial objects, including brown dwarfs and rogue planets. These missions will contribute valuable data that can inform our understanding of stellar evolution. Education and public engagement also play a vital role in the future of astronomy. By inspiring the next generation of scientists and fostering a sense of curiosity about the universe, we can ensure that the quest to understand celestial mysteries continues. The exploration of whether stars can turn into planets captivates anyone with a sense of wonder about the universe. Encouraging curiosity and discussion fosters a deeper appreciation of astronomy. Engage through observation. Amateur astronomers contribute by observing celestial objects. Citizen science projects offer public participation in research. Forums, social media, and workshops provide spaces to share and learn. Open dialogue builds a community of curious individuals. Fostering curiosity inspires wonder and a desire to understand the universe. Hey everyone! If you enjoyed this video and love exploring the wonders of the universe, make sure to hit that like button. It really helps out the channel. And don't forget to share this video with your friends so they can join in on the cosmic conversation. If you're new here, welcome! Tap that subscribe button and ring the notification bell so you never miss an adventure into the stars. We've got tons more mind-blowing content on the way. Thanks for watching, and I'll see you in the next one. Keep looking up. Thanks for watching, and I'll see you in the next one. Keep looking up.